Welcome back. This video is all about the greatest common factor. What is it? How do you calculate it? Are you ready? Let's get started. Okay, so we're going to define greatest common factors and we're going to show you how to find them for both integers and algebraic expressions. This is the first and foundational step to factoring, so you must understand this well to keep moving forward. So take your time with it, okay? You should already know how to find the prime factorization of a number, but if you don't, there will be a quick review. And here's the review. Write the prime factorizations of 105 and 150. Now, there are many ways to do this, but the goal is to write the number as a product of its prime factors. I'm going to use a factor tree. Your tree may look very different from mine. Doesn't matter as long as we get to the right answer. 105 is equal to 5 times 21. 5 is prime, so we circle it. 21 is equal to 3 times 7. 3 and 7 are both prime, so we circle both. So 105 is written as 3 times 5 times 7. Moving on, 150 is equal to 5 times 30. 5 is prime, so we circle it. 30 is equal to 5 times 6. 5 is prime, so we circle that. You're getting how this goes? 6 is equal to 2 times 3. 2 and 3 are both prime, so we circle both. So 150 is written as 2 times 3 times 5 squared. Review done. So what is a greatest common factor? Well, when a factor is shared between two or more numbers, we call this a common factor. For example, if we use our prime factorization of 105 and 150, it's easy to see that they have 3 and 5 as common factors. And math vocabulary matters. Greatest common factor is the largest shared factor between expressions, and it's just the lowest power of each factor. Now I bet you're wondering, why is it the lowest power? Well, let's write our expressions in expanded form. Okay, so you can see that the lowest power of each will be the shared factor. So think about it, like if I chose 5 squared as my greatest common factor, I only have one 5 in 105. So we have to have the lowest power. Okay, let's go back to our prime factorization form. So we start with our common factors of 3 and 5. The lowest power of 3 is 1. The lowest power of 5 is 1. We multiply 3 times 5, and 15 is our greatest common factor. Good? Okay, pause the video and give this one a try on your own. Restart it when you're ready to go. I'll start. The common factors are, we start with our prime factorization. My common factors are 2 and 11. The lowest power of 2 is 2, and the lowest power of 11 is 1. I multiply 2 squared times 11 to get 44. So let's be honest, those last two examples, you could probably do them in your head with sets of factors and no factor tree and no prime factorization. Here's where our method really kicks into high gear. Variable expressions. Suppose we need to find the GCF of the expressions below. We start with our prime factorization and we look for our common factors, in this case, P and R. And the lowest power of P is 1. The lowest power of R is 2. We multiply and we get PR squared. Oh, look at my sad PR squared. Gotta get that aligned. All right. Why don't you guys try this one on your own? Pause and restart when you're ready. I'm gonna start now. Here's my prime factorization. We have common factors of 2, 3, B, and C. Whew, lots. My lowest powers, and I multiply to get 12BC squared. Now, if you didn't get the right answer, feel free to pause, go back, write down some notes before we move on. Suppose we need to find the GCF of the expressions below. Wow, lots of stuff. Do not let that intimidate you. We can find the greatest common factor even when it's not a monomial. It can be any kind of polynomial. So let's start by writing this in prime factorization form. Do you see the common factors? Very good. They are 3 and x plus y. Not x, not y, but x plus y. And then we follow the same steps. Let's bring our prime factors down below, our shared factors, sorry. The lowest power of 3 is 1. The lowest power of x plus y is 2. So our GCF is 3 times x plus y squared. All right, what's the point? To find the greatest common factor, we factor our expressions, we find the common factors, the shared factors, and then we find the lowest power of each of those factors. And the GCF can be any kind of polynomial, a monomial, binomial, etc. That's it. And we're done. I will see you in the next one. The next one is how to factor using the GCF.